So today we'll start with lesson 4, which is using the indicators. And as the objective of this lesson is we will see how can we estimate the pH and pOH of a compound using indicators and see how we can read the colors that the indicators are giving us. Okay, so let's start now. Indicators are used to determine the pH of an unknown compound, a known substance. So if we don't know what is the pH of something, of a compound, then what do is we use different indicators to see what is the color change. And this is a qualitative analysis. Color change. In a chemical reaction, acids lose the hydrogen ion and bases gain the hydrogen ion. Indicators are weak acids or bases. And what will happen is when we put the indicator into the solution, the color will change. Responding to the pH that the solution has. Right. Some indicators have only one hydrogen. Some indicators have only one hydrogen, and they are capable of one color, one change color. So let's say that we have the methanol, orange. First of all, the indicators are found in your data booklet on page 10, and there are a bunch of indicators. What we will focus on chemistry 20 is everything besides the last column, that is the Ka value. So we'll not deal with it. You will deal with it on Chem 30. However, what we will see is mostly what is the indicator, the type of indicator, the pH range, and the color. So those will be the three columns that we will use the most. However, let's see methyl orange, which is H, you have it there, HMO, aqueous, and MO. So this is giving you, HMO is giving you the red color. And where is it? MO, this is HMO, yeah, MO minus is giving you the yellow one, the yellow color. So now, the range of the pH is from 3.2 to 4.4, as you see it here on the third column of methyl orange. And then the colors are red to yellow. Okay, so if the pH of a substance is below 3.2, then the unknown indicator, for the unknown, then the unknown solution will turn red when we put this methyl orange. If the pH was between 3.2 and 4.4, then the indicator, when we put methyl orange on on its solution will turn orange. Why? Because it between red and yellow is orange. And if the pH was above 4.4, then will turn into yellow. But there are other indicators that have more than one hydrogen. So those are called, if those, the first one are called monoprotic. Monoprotic indicators. Those are called polyprotic indicators. So what this is saying that they have more than one. Other indicators are called more than one hydrogen, and they can have multiple color change. Let's say phenyl blue. For phenyl blue, you have H2TB aqueous is red. HTB minus aqueous, which is yellow. And then the last one is TB2 minus, which is blue. Okay. So now what we have there is that if the pH is between 1.2 and 9.6. If the pH was below 1.2, then the color will be red. The color of the indicator will be red. If the pH is between 2.8 and 8.0, 2.8 and 8.0 will be yellow. And if the pH is above 9.6, then the color will be blue. Let's see now how can we use those indicators when we have to define the pH of the unknown substance. So we have two indicators that we are using, methyl orange and phenyl blue. And when we are putting those into a solution, the methyl orange will turn red and methyl blue will turn yellow. So methyl red, where's it? Methyl red is 4.8 to 6.0. Okay. So for methyl red, we will have 4.8 to 6.0. And what we have is a red color. So that means that is less than. The pH is less than 4.8. What do I have is this something in here, pH. And then we have phenyl blue, which is yellow, which means that is between 2.8 and 8.0. Okay, it's 2.8 to 8.0. So 2.8 is somewhere in here. Let's change the color. 2.8 is somewhere in here, and 8.0 is somewhere in here. So as a result of this, we will have this interval that the pH can be based on that indicator. Now, as you see here, there is an overlap between 2.8 and 4.8. So you can say that the pH is on the range of 2.8 to 4.8. Okay. And then you can define if it is an acid or if it is a base or whatever. Let's take a look on the other one. So it's pretty much building the number line and see where they overlap. So now what we have is a bromothionyl blue, and it is between 6.0 and 7.6, and the color is blue. That is an indication that the pH is greater than 7.6. And phenolphthalein is between 8.2 and 10.0, and this is colorless, which means that is less than 8.2. So if we draw the number line now, then we have 7.6 here and 8.2 here. Now from the bromothionyl blue, we have greater than 7.6. So we have everything that is in this direction in the black color. And what we have for phenolphthalein is less than 8.5. So this one here. And where those two overlap is the pH is between 7.6 and 8.2. And this will be the answer in terms of this solution. Okay. Now the third one is having more than two indicators that we are using. So the first one is colorless, which means that we are having a pH that is less than 8.2 based on the colors that we have here. Because phenolphthalein is colorless, which means that is less than 8.2. Bromothionyl blue is turned blue, which means that is greater than 7.6. And phenol red is between 6.6 and 8.0, and it is turned red, so that means that is greater than 8. So let's build the number lines here. So what we have as numbers are 7.6, 8.0, and 8.2. So one is less than 8.2 for phenolphthalein. So this is less than 8.6. Next one is less than greater than 7.6. So it is this one here. And the third one is greater than 8.0. So it starts here and then greater than 8.0. Those three will overlap on this interval here. So you can state that the pH is between 8.0 and 8.2. The more indicators you use, the more accurate it is. when you are selecting an indicator, you want to determine if you are working with an acid or with a base. Okay, so because those are the two that indicators work for. If it is an acid, then you will see that the pH is at a certain range. Okay, so now therefore the indicators like bromethylum, bromothiol blue makes sense if the pH is below 7. Then if the pH is below 7, then the unknown will be an acid, as always. And if it is above 7, then will be a base. For example, when we have an unknown turns the indicator bromethylum blue on blue, therefore this is a base. Okay, this is a base because it has a pH that is above 7. And now which indicator would make sense? When we take a look at the methyl orange and phenolphthalein, then we notice that phenolphthalein will make more sense to use because this indicator tests between 8.2 and 10, which is a basic. Okay, we are testing a basic, so then we will take a look at the indicator that is at the range that is above 7. Okay, this is the lesson, and now you can work on the assignment, just identifying the pH range and the concentration and saying if it is an acid or if it is a base. Okay.